Hello and welcome to Mike Dolan Games. I'm Mike, and this is the next installment in our behavior tree tutorials, making a behavior tree AI system in Unity. It's also part of our Make a Space Game in Unity tutorial. So um, basically going through the steps to roll your own behavior tree AI. Um, it's a pretty cool way to set up AI, and but it can be used in space games as well as first-person shooters and any type of AI where you might want to have your AI make some interesting decisions. It might be a little bit overly complex for super simple games, but if there's a lot of things that your NPCs can do, a behavior tree is probably the way to go. So today, this is our second tutorial on behavior trees, and we've already got the basics set up to have our ships fly around, find random wander points. And we're going to expand on that today and basically set up a way for the NPCs to choose between whether they want to find a random point or whether they want to chase another ship and attack it. So we'll focus on finding the player and attacking, but as you can see in this demo, well, not anymore, I guess they destroyed them all, but as you can see in this demo, we have the AIs actually fighting each other. So they can target each other and attack each other. And you'll be able to do that too with this tutorial. So, but to start off, for this video, we're just going to set it up so that they select the targets and chase them. And then in our next tutorial, we'll set up the attack behaviors as well. So without further ado, let's get started on this. So I'm going to get out of my demo version here, and we'll open up our tutorial. So make sure you open up your Unity tutorial project that you've been using to follow along here, and we'll get started. So we'll just open up our editor. So I'm using Visual Studio, and this is the BT node. So just to refresh your memory on this, this is the base class that we use to create any type of behavior for our behavior tree. And actually, since the last time that we had a video, I actually set up a code snippet and for myself so that I could build our behavior tree nodes faster. So I wonder if I can open this up and show you. Maybe I can't. Well, we can copy it. Well, let's try open file. I'm just going to do this quickly so I can show you. And so I'm storing this inside my, you could import it actually to your code snippets. And so a code snippet in the Visual Studio is basically like an XML file, but it uses the .snippet file name. And so it's an XML file. It follows this kind of code here. Basically the main part that you need other than snippet is the code, and then you can actually put your C# code right inside this C data thing here, and then you can kind of give it a name and a tooltip and things like that. Once you do that, you can import it with Tools, Code Snippet Manager, and you can add a new one, and then it will look for it. So wherever you saved it, you can add it here, and you'll see here. Where's the shortcut I gave it is BT node. So now, when I want to make a new behavior, I can just type in BT node and press tab, and it will build kind of the structure of a new node for our class. So you'll see that in a second. Okay, so our main class for running our behavior tree is our AI controller. This is a controller input based off the interface controller input, and also it's a behavior AI interface as well. So it implements both of these interfaces, and that's important because we want to control our ship controller, and then we also just need a way to allow our behavior tree to interface with this controller. So using the AI behavior allows us to kind of pass in information, and we could always create a new AI, and as long as it has the AI behavior interface, we can use the behavior tree with it. So that's why we're doing that. Okay, so I think we'll start by kind of mapping out our behavior tree here, and then we'll add our different behaviors that we need to make this work. So we're going to have, let's see here. So we have our list of behaviors here. We have our root, which is the one that runs every update. We have a check arrival sequence, and we have a move sequence. We're going to need a few more, okay, to define here as sequences and selectors. So to really get this to work, we're going to need another sequence called decide to attack. Basically, this is going to choose whether it's going to attack or not. And then if it succeeds, it will chase the target, chase the player, or whatever it's chasing. And then we're going to have a selector called select target type. Okay, so we're going to need the sequence and the selector, and then we're going to need a couple of different behavior tasks to make these things work. Okay, so now we're going to have a root AI, we're going to have a check arrival sequence, a move sequence, decide to attack, and select target type. Okay. Another thing we're going to add to this AI script, the AI controller, is our AI is now going to have a game object target. Okay, so before we had a target that was just a vector3, kind of where we're headed to. That's this my target position here. But now we're going to also track a game object, and we're going to set it to null because we're going to check if target's null, then we're not actually chasing something, we're just going to a vector3. So we're going to set it to null in the beginning just in case, and then when we want to set it, we'll set it, and we'll have some logic to make sure our behavior tree knows whether we're going somewhere or chasing something. All right, and then the last thing to make things interesting, this is how we implement our kind of AI fighting AI, is we're going to have a enemy faction, and this can be expanded out. You might need an array or some sort of lookup table for which factions are fighting which factions, but right now we're just going to have everyone's going to be on either the player team or the enemy team. So right now we're going to default the AI to want to attack the player faction. Okay, and so we could set a tag for an AI to be part of the player faction, and then they'll be on the player's team, and they won't attack the player, they'll just attack the enemies. Okay, so yeah, so we've created these sequences and selectors, so now we can define them. So the first one we're going to define, actually, because we need to define everything in order, basically. So if you're going to use one of these sequences later on, you need to define it up at the top. So I mean, that's important. It won't be able to find it and use it later. So we're going to define the decide to attack equals new, and this is a sequence because it's making a choice. New BT node, and then okay. All right, so now we have our decide to attack sequence, and we're going to have two new behavior tasks in this. Okay, so we're going to have something called a random chance conditional, and I'm calling it a conditional because I think that we're probably going to have more types of conditionals as a type of task. These are just things that are going to like represent like if-then statements or switch cases, or this one's going to roll a random number and decide if it's higher than the number that we give it, then it succeeds, and if not, it fails. Okay, and so we're going to have a random chance conditional that's going to roll a dice, and if it succeeds, we're going to find, instead of wander point task, we're going to find new target task. All right, and here we go. Okay, so the random conditional is actually going to take three things, and then the find target task is going to take two things. So I guess we should define these because they're red and they're not happy. I wonder if you could generate class. So you could, but oh, you can. Wow, I never thought of doing this. Okay, so once you type these, if you right click, go to your, or just hover over, click the light bulb, and it says generate class random chance conditional in a new file, and that will save us some time. We click that, and we'll get this. Not exactly what we want though. Okay, so if you look at our things, actually we don't need all this stuff, I guess, but usually in our in these things we're gonna have, and I've been using public for this. I gotta work on my scoping. It's one of my things I need to figure out here. Not everything needs to be public, but it's really easy to make everything public in Unity because then you can see it in the inspector. Not that a lot of these classes can be seen in the inspector, but it kind of becomes a habit. Okay, so we're gonna have this, yeah, okay, and yeah, one thing this is gonna do is it's not okay. So yeah, so we need our evaluate because we have it's a BT node. Okay. The other thing we need is we need to set up our constructor. And what else do we need to do? We need to show off my really cool snippet. So, like I said before, if I type in BT node, it wasn't working before. BT node. There we go. Okay, so you just type in your snippet, and then you can and you press tab, and it will like fill in kind of your boilerplate. So that's what I've been doing. Okay, so it kind of just sets up some of the stuff that I want here. Now this boilerplate is actually not that great, but okay, so we have our random chance conditional as our constructor, and now we are going to let's see here. We need a couple things. We're going to need our we're going to need 3 different integers. Okay, so we're going to need an integer for the number of sides of a dice, how many dice we're going to have, the number of sides, and then what number we want to beat. Okay, so let's all right, so let's set that up. Okay. All right. All right, so in here we have our number of dice, int number of sides, int number to beat. Okay, and then in here we will do the same thing. Dice int number sides and int number to beat. Okay, and since this is our constructor, we need to just set our variables up. So number of dice equals number of dice. Oops. Number of sides equals number of sides. Number to beat equals number to beat. All right, and basically this task is just going to basically roll a dice or a number of dice. So you could apply this to a like an RPG if you wanted to build in an AI behavior that did an attack roll or something like that. You could use this this behavior. So we're going to save a total because we're going to loop through our loop through the dice. So I less than number of dice plus plus. Okay. So this way we set it up so we can have make the number whatever we want to test against. Random.range, and so we're just using random.range, and this is an integer, so it's going to take the lowest integer, and then it's going to take the max integer, but the max integer actually is exclusive for integers. So with floats it's inclusive. What this means is that if we did a random range between 1 and 6 for like a 6-sided die, we would only roll actually a 1 to 5. So we need to do number of sides plus 1 to get the actual dice number of sides for this random range. Okay, once we've rolled and we've totaled, now we have our if statement, and so if total is greater than number to beat, then we return a success, else we return failure. Okay, so this is basically the random conditional. Okay, and we're going to put in these numbers into our AI controller. Oops, I've lost it. So find your AI controller. All right. So in here, we'll say, well, you can always look. Okay, we need number of dice, 1. How many sides? 100. And number to beat, 50. So kind of like a 50% chance of doing this task. Okay, so now we need our find new target task. Okay, so this is the one that's going to, if we roll the right number, we're going to then look and try to find a target. Okay, so generate a new file, and we'll just ptnode. Okay, and we'll take this, put it here, and snippets will actually allow you to fill these in when you first load it, but it's fine the way it is. This is weird. I've got this weird pointer now. Okay, all right, so we have our find target task, ptnode, and we have our constructor. Okay, so what does the find target task need? The find new target task. We're going to get a, so this one we need to have access to our interface, our behavior AI interface. Let's give it AI. Okay, and we're going to need a string for faction. I guess we'll call it enemy faction so we're not confused. So, all right, so we're passing in this enemy faction, and in here, my behavior, my AI, and string enemy faction. So in our constructor, make sure you pass in these variables, and then we'll set them like we do. And equals enemy faction. All right. So now once we have these set up, we're going to evaluate. Okay. So whenever we run this, we're going to need to figure out a finding a target. Okay. So the first thing we can do is game object. We're going to make an array of game objects that are targets. And this way we can kind of find all the targets that are objects with the tag of our enemy faction. All right. So now we're just grabbing all the game objects in the whole game that have this tag. There are better ways to do a faction system, but this is kind of the quick way to do it for now. We probably want some sort of enemy or ship manager in the future. or a component instead of a tag that we can look for. And then once we grab those, we're going to do a random choice. Yeah. Random. And we're going to choose between all of the game objects that we just found. So targets.length. All right, and then AI.set. So right now we have set target position. We need a new method inside our interface that allows us to set the target that we want. So it's going to give us a hard time because we don't have that. It doesn't exist yet. Okay, so in here we're going to do targets and then whatever our random choice was. All right, so we're going to have to add this to our like we can just generate this inside our behavior AI. Did I just do that? Did that just happen? I don't even know. Yeah, it did. Okay. The magic of Visual Studio. Okay, so we just did that. We'll go look at that in a second. But we just added a method that doesn't do anything to our interface for setting the target. Okay, so once we have that, then we can return success. One thing I was thinking about is this this whole thing in here basically could probably go inside this this if statement, right? Because we're checking whether something's true and we're returning success because we found our target. But what if there is no enemy in our faction? So this happens like in the current demo where if they destroy all the targets, then there's no targets left, so we get an error. So you could just do this, like if target length is greater than 0, then we'll set our target. Else we'll just return failure. Okay, we didn't find any targets. So that's a good way to do that. Okay, that should work. All right, let's go look at our behavior interface because we just added something. So here you go. We added a set target game object method, and I'm going to have it just return game object. I'm having all these kind of return the thing that they're doing. So I don't think I'm going to actually use that for anything in the future. So maybe we can change it, but it could be useful to see what we set maybe. Okay, so so we have that. All right. And so now we have two of the most important parts of this this new behavior idea. So can I delete, just like close off some of this stuff? Yeah, let's do that. Find wander point. Let's close that one. Okay. So now we have that. We have our ship controller. We don't care about this right now. We have our AI controller. Okay. So now we have to implement this correctly. So we need our AI. So you just do this. So it refers to the interface that's connected to the AI controller. And then we need our enemy faction, which we've defined already. Okay, so now we have these two things. Now we have our decide to attack, which is very cool. Okay, so what else do we need to do? Let's think about this. We defined another selector called select target type. Okay, so we can put that one just beneath the decide to attack. Okay, and we will do that. Select target type equals new selector. Of course, selector. It's not autofilling. Okay. Didn't do anything. New list nodes. Okay, so So I messed this up. Oh, I just need to, okay. All right. Okay, so now we have our selector, and we are going to add some logic here to decide what type of target we're going to go to. So one of them is decide to attack. All right, and so we will call this one. And if we do not decide to attack, then we will call the find wander, the find wander point task, which is this one. Okay, so if we have these two things, we probably, let's think about this. So we have our find wander tag. Okay, and the next thing we want to do is in this arrival sequence. Right now, this is just checking if we get to the waypoint that we want to get to, but we can reuse this because it can decide if we got too close to the thing we were attacking, and then kind of reset the whole thing. So this is kind of where we would want to use our select target type. Yeah, select target type. Right? So we have our select target type now. So now when we arrive at the thing that we're going to select. So then we're going to decide, do we attack or do we find a new wander point? All right, let's see. What else do we need? This is fine for the route. And then we can continue to find wander point for this. So now our route AI is going to evaluate each update. It's going to check our arrival. Did we get close enough? If not, we'll keep moving. And if we did, then we're going to decide whether we want to select attack or find another wander point. Inside decide to attack, we roll a random dice. If it's good, we'll find a new target to attack, and then we'll set that. And if not, then we will just wander. Okay, so we're still missing a couple key pieces here. One of them is that we've set the target, but we can't really, we're currently not going to move to that target because we haven't implemented set target, right? And so we have to do that. And then also, the other thing we haven't actually done yet is we don't want to call this game object. We'll call this target or new target. Okay, target equals new target. So now when we set our target, okay, yeah, and then return target. Okay, so now we can set our target. Then the other thing we need to do is in target position. Right now, this is just using the target position of the vector that we're looking for. We want to do something here where if our target is not null, so if we have a game object being stored for our target, we're going to return our target. Our target dot transform dot position. So now anytime we ask for this, we're going to check to see if we have a target game object. If we do, we're going to return that. If not, we'll return our vector target. Oops, I did this in the wrong place. Okay, we don't want to do this here. That's for setting the target position. We actually want to do it here in the getting. Okay, so if we ask for a target position, we're going to decide whether we're chasing something or not. Okay, so make sure you put it in here. Don't put it up there. Okay. Next, the other thing is we need to make sure we set our target to null when we are deciding to wander. So let's save this and go into our. I would say the best place to put it probably right now is this find wander point. Okay, and we're finding our wander point here in the evaluate. So we're going to set our target to null. And luckily we have a myAI dot set target, and we can just set it to null like that. Okay, so now when we're finding a wander point, we're just going to say we're not chasing anything anymore, get rid of it, and we'll wander. Okay, in the future you might want to have more complex behavior where we're actually like remembering what things we're attacking. So maybe you take a new vector of attack, so you fly out and then you come back, you know, attacking the same target. This one's just going to keep randomly picking things, so which is fine. But yeah, that's kind of you know, we can always make this more complex because it's behavior tree. So all right, so we have that. This is fine. This is fine. Okay. We have our target set up. And the one other thing, I don't know, I can't remember if we need this. Okay, let's see if this works. Okay, so we have kind of our basic sequence. We have our different new tasks. We have our AI tree here, our behavior tree here. All right, so if we go into our game tutorial, we should have an enemy ship that already has the AI controller on it. It has a enemy faction, a player faction. One last thing we have to set up. Okay, so in our tags, we need to add some tags. So I have a player faction. I'm going to add an enemy faction too, just so we can make this interesting. Okay, so you need a tag for player faction and one for our enemy faction. The player is going to be set. So right now, this object called ship is our player ship. So just tag that as player faction. And then on the enemy, you can tag that as enemy faction. Now, if we press play, hopefully we see, let's see, the enemy ship will, okay, so I have him really cranked up to go really fast. I have no idea if he's chasing us. Okay. Let's slow him down a little bit. Okay. Sure. He'll turn fast, but okay. So here he comes. Move to target task is what he's doing right now. So he kind of looks like he's... Doesn't look like he's following us at all, huh? It doesn't look like he's broken. But... he definitely doesn't seem to be making any dice rolls that are... it didn't look like he was choosing our ship to chase after. Let's look at the code real quick, just make sure we don't have any bugs here. Okay, so okay, so we have our wander point. We're going to go to our wander point. We're going to check our arrival sequence and move towards it. if we go to check arrival, we're going to check our arrival task. If we succeed, we're going to select a new target type. If we select a new target type, we're going to either decide to attack, and if we do that, we're going to roll random dice and then attack. So find a new target task with our enemy faction in it, player faction. That should work. Let's just double check our check arrival task here. We're getting our target position to decide our, yeah, that should be fine. Okay, let's make our dice roll a little bit more, okay, two things we're going to do. We're going to put a, we're going to put a debug in here. Okay, so if target's length is greater than 0, right? Enemy faction, enemy faction, enemy faction. Set target to game objects. Okay, so this should all work. Let's do a debug log here. Yeah, this is just how AI works sometimes, especially in kind of a black box type situation here like this. Found target, and let's see, targets, and we'll do random choice like that. Dot name. The only name that should pop up is ship, right? Okay. Yeah, we'll just plus it. All right, and then if we're failing, that's interesting. Okay, and we'll put in a failed to find target. Okay, it's possible that our check here, targets.length, is coming back negative, you know, with a 0 or something. Okay, so it shouldn't, because we've labeled our player, and with our player faction, that should be correct. We can double check here. Player faction looks good. All right, our enemy ship is looking for player faction, not misspelled. All right, let's try this again. I think. Kind of want him to go a little faster. All right, he does not look like he is chasing us though, does he? Let's look. Okay. Now if we collapse our debug log, we can sort of see what's happening here. So far we haven't chosen chase the player yet. Okay, so let's go back into our AI controller again, and we're going to make this the number to beat 10. Okay, let's just see if that does anything. And okay. So now he is definitely super fast. Okay, So you'll see here in the debug that he did find the target ship, and then he was finding a wander point. So let's see if we can. The other thing we can do. Oh, I don't have. Yeah, we don't have that. Okay, so sometimes I put like a debug line on these guys to see where they're going, stuff like that. All right, where are you? There he is. Looks like he's chasing me. Now he's going away. Let's see if he comes back. So I think the weird issue was we were just having bad dice rolls to demonstrate the behavior. Looks to me like he's coming for me. Okay, so this is the behavior for now that we're looking at here. I guess this guy has a he has a gun on him, and he's chasing me. Okay, so one cool thing that you can do right now with your enemy ship is just before we wrap up this video, give your ship a trail. Okay, and let's see here. Let me show you the trail. Can I break this out? Yeah, okay. So let's, all right, so this trail here is kind of what you want to do. So get a trail renderer with the color. I like a little bit of faded on the front and the back, and blend mode, and then time is 15, width is just 1 straight across. That's kind of it, default line. All right, so let's see. We can create that here. So go in here. I'll show you just how to do it. Select a yellow. You know what? We'll make this guy orange, and then orange again. Okay, a little different oranges. Sure, why not? We'll do that. And then this one. All right, so we're fading on both ends here, like that. Okay, and then put this up to 15. That's fine, that's fine, that's fine. Default 1. Okay, that's basically it. Okay, so now if you play your ship, they should have a line, and that will give you kind of an idea of like what the AI has been doing. He's not moving very fast, and you can play with the speed, obviously, on the ship controller, but it's good to kind of have like that trail in the back. It will help you kind of like visualize what they're doing. All right. I think I like him just a little bit faster. Let's try 5,000 for the. There you go. Well, that's really fast, but making your AI too fast will mean it's going to be really hard to hit him. So, ooh, he hit me. All right, so that about wraps it up for this video. I think it's gone long enough. Next video, hopefully I'll be able to get to it tomorrow or the next day, so Saturday or Sunday, and we can add the lasers and things to our enemy AI. You can also try to do it yourself if you want. Basically, you're just setting up a behavior that fires the fire event when the enemy is near, when the enemy is kind of in front of you. So, yeah, there's a couple different behaviors that you want to set up for that, but and I'll show you that. So, is it in range? Is it is it not obstructed? So, Anyway, hope you enjoyed this tutorial. Please like and subscribe and share it with your friends who might be interested in making space games. Thank you for your patience. You'll hopefully will have a demo like this in our next video so that you can try this too, and we can talk about adding some effects and things like that afterwards if you want, like some thrusters and things like that, and how to make the lasers a little bit cooler than what we have in our demo, our current tutorial demo. But always feel free to make your game look how you want it. There's lots of Unity assets that you can probably plug right into this tutorial series to make it work. All right, well, thank you for your time, and hope you enjoyed this video, and have a great night.